Hello everyone. Today I'm going to present a work called Two-Level Data Augmentation for Calibrated Multiview Detection. Multiview data is scarce and datasets for detection are usually small due to the high cost of annotating multiple views. Recent models can easily overfit such small datasets. To limit this overfitting, one could try to use data augmentation. However, such models tend to rely on strong alignment between views, and naive data augmentation can easily break this alignment. So let me first introduce a typical multi-view detection model. So each view are processed independently by a feature extractor that is called view network in this diagram. Then those features are projected into a common representation with pre-computed projection, T1, T2, TV. And all those projected features are aggregated by a scene network, and the final prediction is done at the scene level. To align our multiple view, we project them onto a common ground plane. These projections are computed from the parameter of the calibrated cameras. In the animation currently playing, you can see how the different views are projected onto this ground plane. Once projected onto this common ground plane, multiple views can easily be aggregated since they are spatially aligned. Now that we have presented our multi-view detection model and projection onto the ground plane work, let us introduce our multi-view data augmentation pipeline. First, we propose to do view augmentation. Each view can be augmented with traditional geometric augmentation such as random cropping, flipping, random affine, and perspective transfer. The augmentation are applied on the original image, and the augmented image goes through the view network to improve its generalization capability. Each augmentation can be characterized by an homography, and knowing this homography, we can update the original projection into the ground plane to preserve the alignment between views. Since view augmentation preserves the alignment with the original ground plane, it has minimal effect on the scene network. To also reduce overfitting in that part of the model, we propose a second level of augmentation that we call scene augmentation. This augmentation is applied after the projection onto the ground plane and is the same for all the views. As you can see on the illustration on the left, after applying a affine transform at the scene level, the original ground plane is deformed, but the alignment between views is preserved. Now, by combining both types of augmentation, we can reduce overfitting in the view network and in the scene network. On the left side, we visualize both types of augmentation. With our simple two-level data augmentation pipeline, we were able to obtain state-of-the-art multi-view detection results on WILDTRACK and MultiviewX by systematically reducing overfitting. Thank you for your attention. The code for our work is publicly available. Check out the paper for more details and experiment, and please come talk with us at our poster session.